Okay guys, so 13.4, I'm gonna like sort of race through the first page because the second page I want to take a little bit more time with. But the gist of the first page is that what we've been doing where we take the average rate of change. So this is like the average rate of change right here. The limit as x approaches, 1, f of x minus 1 over x minus 1. That is, guys, that's me. That's m tan. That is the slope of the tangent line. So what's a slope of a tangent line? The slope of a tangent line is literally like, so here's the graph. If you take a tangent line, like on our roller coaster ride, and we say this has a slope of 0 on the very bottom, on the very top, over here there's a positive slope for that tangent line. That's the tangent line. And this is the slope of the tangent line. So I highlighted it here. If you could do some highlights, that would be awesome. So this is the tangent line problems and derivatives. So what we're finding are actually derivatives. Derivatives are slope of the tangent line. When you take calculus, you're going to hear the word derivative a lot, and I'm going to say, what's a derivative? And you're going to be like, that's the tangent line. Okay, so tangent line slope, okay? The tangent line itself is when you take that limit and you find that limit, and then that's the slope, and then see that formula is totally normal. So this is like y minus y sub 1 equals slope times x minus x sub 1, and then again, slope of the tangent line. There's so many different ways of saying slope of the tangent line, m tan. They all mean me, okay? I'm totally serious. They all mean m tan, the slope of the tangent line. How else can you say it? You can say it like this. The derivative of f at c is slope of the tangent line. F prime of c is slope of the tangent line. This is m tan. This is m tan. They're all m tan. Everything I'm highlighting is m tan, okay? The reason I'm kind of going through this pretty quickly is because we've already done this part where you find 1/2. So like in our other notes, we've done, the derivatives, but it wasn't called derivatives. It was called average rate of change. So we've done this average rate of change. We get 1/2. And then all we do now is we plug into y minus y sub 1 equals slope of the tangent line times x minus x sub 1. Where do we get the x and y from? They give it to you in the problem. What if they don't give you a y value? If they don't give you a y value, you take the 1, you plug it in, and you find the y value. Okay. The derivative, again, same thing, is m tan. So you guys try this one with this function. You're doing the same thing. So this should be really familiar. You did this on the quiz as well. But then your last step is to, you're going to check it. And then sometimes they ask for the equation of the tangent line. And that's where you would plug this into y minus y sub 1 equals 3 times x minus x sub 1. Okay? If they ask for the equation of the tangent line, this is the slope of the tangent line. So you have to do the work. Don't just say 3. So hopefully you get 3. If you don't, ask me on Monday or Tuesday. Right here on your calculator. So I'm going to open my calculator right now and I'm going to show you. So on Desmos, on your calculator, on something, so you're going to use your graphing calculator and they will give you an answer for slope of the tangent line. You have to sometimes get your answer from a calculator next year. But you can do it by hand like we did, and you can check it at any time using the calculator. So what you would do is, it says right here, but I'm going to show you. So you do math, and then if you scroll down to 8, or if you just press 8, I can literally just press 8, it's the derivative. So this means I'm finding the derivative in terms of x. So find the derivative in terms of x. And then what is the function? And I'm going to write in the function 2x squared minus 5x. And then now, they're not going to just give you the derivative, they give you a derivative at an x equals. So we want to know when x equals 4. So then we put when x equals 4, press enter, and the answer is 11. There you go. So if you did it the long way, this way, the way you did it over here, or you did it with the calculator, you get the same answer. You're going to try number 2 with the graphing calculator, and I'm hoping that you get 3. What does differentiable mean? Differentiable just means you can get a it means you can get a derivative at that place for the x value. That's what differentiable means. Like if something's differentiable at x equals 5, there is a slope at x equals 5. That's all it means, okay? The instantaneous rate of change, that is n tan. That is the same thing. So they're using all these different wordings to get the same thing, okay? So that's part of like the quiz for 13.4 as well for this chapter, is to realize all these different ways they're asking for the same thing, which is the slope of the tangent line. So a problem like this, I circled a couple things. So I said, okay, there's a lot of words involved. The volume of a right cylinder, here is the height. The cylinder, imagine the cylinder, it's like, what's a cylinder? Like a can of Coke, right? Like a can. So they give you the volume, so nice of them. If R is changing, so R is your like X value, right? It's V in terms of R. And then H is always 6. That's what they're telling you here. Find the instantaneous rate of change of the volume with respect to the radius when the radius is exactly 3. So this is like our y value, the r is like our x value, and the h is actually just 6. So I wrote down some important information, I circled, underlined some important information, and then in my next step, I plug in my 6, and I make my equation look a little bit easier. So there's volume, and then now I want to find m tan for this, and I want it when r equals 3. So then I do my formula. So just like before, the limit as r approaches 3 of v of r minus v of 3 over r minus 3. And then I get my final answer. And this is really weird. I know the way you're rating it is going to be weird, but it is a volume, which is feet cubed, with respect to radius, and radius is in feet. So volume is the feet cubed, with respect to is per, and then radius is in feet. So that's why it's feet cubed per feet. So it's not feet squared. You don't like reduce this or anything. Okay, so final answer. All right, for the back. Okay, so on the back, instantaneous speed is, again, m tan, that's me. So speed is going to be the change in position over the change in time. So basically it's still like the change in y over the change in x. It's the same thing, okay? Do you get to memorize this part over here? Not really, but just realize you're still doing the same thing. Okay, so I'm going to read this problem. It's kind of got a lot going on, okay? So the height of a ball, is this. So with an initial speed of blah, 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 so whatever. But this is the formula for height. I know it's weird because this says S instead of H, but that's the formula for height, and they give you everything you need here. So even if you don't read that part of the problem, it's okay. They give you the formula right here, where T is time, and then that's the time the ball is in the air. So and then it misses the ground from a rooftop. So you throw it straight up into the air, so really straight up, but that's okay. I need it to be like this shape. So you throw it up, and then it misses the rooftop, and then it goes down, and then it hits the ground. So this is the situation that we're dealing with, okay? When does the ball hit the ground? Okay, so if this is the height, we want to know when the height is 0. So we set height equal to 0. You set the equation equal to 0. You divide by -16. You factor, like you already know how. And then you have 2 values. These 2 values should make sense. This is -1, which is weird, right? But if you think about this, this shape is a parabola. So really, this is halfway for the parabola, and then this is 6, and then this is 0 time, but this is -1. So if you went backwards in time, it would take 1 second for this to happen. But then instead of this, we started at time equals 0. So this is -1 technically, like that point right there. Okay? At what time t will the ball pass the rooftop on its way down? Okay, So if you are throwing it up and then you're throwing it this way, we want to know what time this is right here. So the height right here is 96, right? So like this is 96 and this is 96. So we set the height equal to 96. We subtract it to the other side. We, and then you factor, and then you get 0 and 5. Okay, that makes sense, because if we're just talking about this right here, this is 0 time, this is time equals 5. So it took 5 seconds for that to happen. Think about the ball going up, and then it slows down, and then it comes back down. So this is 5 seconds. Okay, before we keep going, how many seconds did it take to get up here? I want you to think about that. If this is a parabola, and this took 5 seconds, right? We know that, right? So it should be symmetric. So that's really 2.5. We'll keep that in mind, okay? At what time, sorry, that was this one. What is the average speed? Okay, average speed is a little bit different. Average speed is old school slope. I said boring, old slope. So this is old school slope. This is what we normally think of as slope, which is y sub 2 minus y sub 1 over over x minus x, right? X sub 2 minus x sub 1. So basically, from 0 to 2, this is f of 2 minus f of 0 over 2 minus 0. So same kind of thing. It's just y's over x's. We plug it in, and we get 48 feet per second. So the average speed of the ball from 0 to 2 seconds is 48 feet per second. That's really fast. The next question is different, and the next question is where we're going to take like a little bit more time. Okay, so you might have to rewind a little bit too. Okay, so what is the instantaneous speed of the ball? Okay, that's different. Instantaneous speed, what is that? That's m tan. Yo, that's me. This is the limit. So how do we do the limit? Okay, we're going to have to write this a bunch of times, and I'm too lazy to write a t with a little 0. So this is like, what's the instantaneous speed of the ball at some random time? I know t sub 0, usually sub 0 means like the beginning time. That's not what they're asking. They're asking some random time. So I wrote it in here, okay? And I said, instead of t sub 0, I want to use another letter because I'm lazy and I don't want to write t sub 0, okay? So I'm going to write c instead of this. So what I'm trying to look for is, I'm trying to look for the derivative, and that's the limit as, this is my x value, so I put t goes to some random time c. And it's going to be s of t minus s of c all over t minus c. So this is like what we've been seeing, right? Except this is a number, and this is usually x. So this is x, a number, but we're just writing it differently. And now we're going to plug in exactly what we did before. So s of t is the original function, the original equation. Minus s of c is the new function where it looks exactly the same, but now we have c's instead of t's, right? S of c. So exactly the same. And then on the bottom we have t minus c still. Okay, so I'm going to do this an interesting way, all right? But I think it's the easiest way. So my 96 is going to minus with my 96 over here. I'm going to get rid of them now. I don't want to have to deal with them. And then what I did in the next step is I got rid of those, and I saw this is a negative 16, and this is going to be a positive 16, and I factored out the negative 16. So this negative 16 and this positive 16, I want to factor that out. And then I have t squared right here. And then I change places. So this is usually here, but I change places. I want to match up my t squared and my c squared, and you'll see why in a second, okay? So this was positive 16 c squared, but I factored out a negative 16, so now it's minus c squared. So I have this one here, and I have this one here. And then if I factor out a negative 16, I would get negative 5t. And then right here, if I factor out, this is a negative 80, right? If I factor out a negative 16, so negative 80 divided by negative 16 is positive 5. So this one, and then this one, and then this one, and then this one. So that's the order I have it here. But you'll notice something really soon about this and why I have it in this order, okay? The bottom is the same. Okay, now look what happened right here and right here. So this is actually grouping, right? So now I can take the difference of squares. This is t plus c, t minus c. And this right here, you can factor out a -5. If you factor out a -5 from both, you get t minus c, because you're factoring out a -5, so that's a minus. And then you'll notice this one and this one, like if you combine them, this is t minus c, and this is t plus c minus 5. But I know that these both are going to divide away with this one, so I just like divide it away right now. And then I get left with the -16, the t plus c, and then the minus 5 right there. So that was like tricky business. Okay, you might have to go back and take a look at that. We're asking on Monday. Okay, and then I'm all good. I divided stuff away from the bottom. Now I can plug in my c value. So now I don't have to write limit anymore. I have -16. I have, instead of t, I'm going to write c. I have this one here. I have the -5. And then I rewrite it as a 2c. And this is my final answer. And I know it looks crazy, but this is my final answer for the derivative for the mtan. And my derivative is the speed of the ball. A speed is like, you know, think of like miles per hour. So it's some sort of, miles is like a distance. And then per hour is a time. So this is my distance and this is my time. In this setting, it's feet per second. So that's my speed. So what's nice about this, even though it looks kind of crazy, what's the instantaneous speed of the ball at t equals 2? This is any random time. So now if t equals 2, I can plug 2 into that. So my s prime of 2, my derivative at 2 is going to be -16. I plug in 2. I get 4 minus 5. This is going to be a -1. I multiply and I get 16 feet per second. So I can say at any time, I can just plug that in and get my instantaneous speed, get my derivative. Okay, so this one, I'm going back to, when is the instantaneous speed of the ball equal to 0? If the instantaneous speed of the ball is equal to 0, we're going to look back at this picture. Oh, my computer keeps doing that, and I'm really sorry. Okay, so if you look back at this picture, when is the speed 0? So the speed is like, well, the speed is, yeah. So imagine when the ball's speed is 0, right? So it goes up, and then it slows down, and then it hits 0, and then it comes back down. So the speed is 0 here. What does mtan stand for? What does instantaneous speed stand for? Mtan is the slope of the tangent line. The tangent line at the very top would be 0. So when the speed is 0, that's the vertex of the parabola. That is like a local maximum. So when does this happen? We already talked about this is 0, this is 5. Halfway is 2.5. If you realize that's okay, but I wrote when the instantaneous speed of the ball is 0, you can also realize that this, which is instantaneous speed, equals 0, and then you can solve for c. So you can get this answer both ways. All right, when is the instantaneous speed of the ball? When it strikes the ground, okay? So when it strikes the ground, when does it strike the ground? At what time are we hitting the ground? We're hitting the ground at 6 seconds. So that's why here, instantaneous speed is s prime, and then we're plugging in 6, and then we get -0.5 feet per second. So when it hits the ground, oh, sorry, not -0.5, -112 feet per second. Okay, so technically this, and I'm not going to mark you off for it. So technically this is velocity, and then speed is always positive. But I mean, in pre-calculus, where it's fine. If you write negative because the ball is literally going down at that time, it's okay. So this would be like positive velocity, and then these all will be negative velocity. So when you find the derivative, these will all be positive derivatives because the slope is positive here. And then these over here will all be negative derivatives because the slope is negative there. Okay, so right now, if this is your answer, it's fine, but technically speed is always positive. So that's why the book's answer is sometimes like positive and yours is negative. Okay, all right, I know that was a lot. The homework is written on the top, so you can jot down the homework for the next couple days. All right, I will see you soon.